All right, good afternoon and welcome to Master Talker online class. In today's video, we'll be talking about refraction of light, okay, through a rectangular and triangular prism, right? We have done a first video on refraction of light. You can go and watch that to help you understand this one better. Then we'll be solving more calculations on this. Now, let me have a rectangle like this. Okay, let me have a rectangle like this. I need to draw it from here. Okay. Don't mind okay. Okay. Let me have this. Let's assume that this is a rectangular glass block. All right. Then let me have my normal. This is my normal. Now, uh, and this is air, okay, and this is a glass. This is a glass. Now, like I told you that what brought about refraction in my former video is when light passes through different media of different density. And I told you that when where a ray of light pass through a less dense medium, you know that air is less dense than glass, which means that glass is denser than air. So since glass is denser than air, we will have that the incident rail, look at the incident rail here. This is the incident rail. Rather, this is the incident rail. Now, if there is no glass here, something will happen. This is supposed to continue moving on a straight line. It's supposed to continue moving on a straight line like this if there is no glass here, right? Now, but due to there is a glass, what will happen? It will deflect. It will change position and then move this way. All right, it will move closer to the normal. Okay, this angle will be greater, angle of incidence will be greater than what? Angle of what? Refraction. Okay, now coming to this place, I'm going to have my normal here. This is the normal. I have my normal here, right? If I have my normal here, then this one is now going to reflect this way. And I hope you know that this one now turns the new incident rail inside this place. But here is alternative angle to this place. So let me call this R1 and R2. You should know that R1 should be equal to R2 because of what? Alternative angle. Alternative angle forms N. Here must be equal to here. Now, and due to the fact that this glass is denser than the air outside, okay? So the refractive index here, the refractive index here, what am I saying? The refractive rail here should be moving away from the normal, okay? That is how you draw it. Look at, let me say it again. This one came in from air, okay? Then the refraction is going closer to the normal. Why? Because air is less dense than what? Than the glass, okay? Then when you form another normal here, this one becomes the new incident rail. This new incident rail will form a refractive rail, okay, that will be moving away from the normal. Why? Because the glass inside is bigger than this, and then we'll call this our what? Our E. We'll call this our E. This E is called the emergency angle. These are emergency angle, okay? This is our what? This is our incident rail. This is our incident rail. Why this our incidence angle? Okay, we have done this before in the previous video. Okay, now while this one now is what? This is the refraction or refracted rail. Okay, why this one is what? Emergency rail. Why this is what? Emergency angle. So this is a emergency rail, while here is our emergency angle. All right. Why this one? This one is the new incident rate. Why here is what? Your refracted angle. Refracted angle. Okay. So now, from this place, we should know there's a law that we know that is the Snell's law. The Snell's law said that what? We did that in the previous video. That what? That the refractive index, from air to glass is equal to what? The sine I over what? Sine R. You know that. And I told you, okay, you should know that what? That light is an electromagnetic wave. Light is an electromagnetic wave, and this means that what? That light travel with the same speed. The right ray travels with what? The same speed with your normal light. Okay, and that permits us to use the general light wave equation. And if you remember the general light wave equation, you said that what? Okay, we should equally know that what? Okay, that v is equal to what? F lambda. You remember this formula? V is equal to what? F lambda. And then you should know that what? That the velocity and the wavelength, okay, differs in different medium due to the density. Okay. The velocity in air is not the same thing with the one in what? In a glass. The same thing, the wavelength in air is not the same thing with the one in glass, but the frequency are the same. The frequency are the same. So you should remember that there's a formula I told you that refractive index is equally what? Velocity in air all over what? The velocity in what? In glass. Okay. And if you do this is equal to what? F lambda of air all over what? F lambda of what? Glass. And you know that the frequency remain the same. So therefore this gave us an important formula that said that V of A all over V of G is equal to what? Lambda of A all over what? Lambda of G. This is an important formula to note, please. Very, very important. Okay. The wavelength in air all over the wavelength in what? In glass is equal to what? Velocity in air all over what? Velocity in glass. Okay. And you know that the light wave, the speed of light is what? 3.0 times 10 raised to power 8. Don't forget that. Okay. This is for rectangular glass prism. So let's talk about the triangular one. Let's see what happened for the triangular glass prism. Then we now solve calculation, and then we are done for this class. All right. So now let's have a triangle, and this triangle must be an equilateral triangle. An equilateral triangle is a triangle that has equal sides and equal angle. Right? It has equal sides and equal angle. So don't know how to draw it to make it equilateral, but just know that what I'm drawing is an equilateral triangle. Okay? My own may not be. Don't mind mine, right? Don't know how to draw something, but let me assume that it is like this. Okay. So now, and you know that the total angle in a triangle is what? 60 degrees. So now, in naming your rectangular glass block, please don't scatter the naming. Don't say that here is A, here is B, here is C, and here is D. This is scattering. It doesn't make sense. Why naming it? It's either you name clockwise or you name anti-clockwise. Okay, if I want to name clockwise, I will say this is A, B, C, and D. This is naming clockwise. You want to name anti-clockwise, you will say what? That it is what? A, B, C, and D. Please, if you scatter it, you will make mistake. That is for your practicals anyways. If you scatter it, you will make mistake. Do not scatter it. Don't scatter it. Just name it either clockwise or anti-clockwise. So if I want to name this one, I can decide to say A, B, C, right? Or you say A, B, C this way, any way you want. Now, let's have a normal here. This is our normal. Just don't mind my drawing anyways. I'm not really that good at drawing. Now, let's have our normal here. Now, if we have our normal, and then we'll now have a ray of light coming this way. Let's have a ray of light that is coming this way. I have a ray of light that is coming this way. Okay. And you know that if this if there is no glass block here, that it should continue like this. It should continue like this, right? It's supposed to continue like this. But because there is a glass block, it will come, it will form something like this. Aha. So now, see what happened. Let me something like this. So to form something like this, so that here our I should be greater than our R. Why? Because air is less dense than glass, right? Or you say that air is you say that glass is denser than what? Than air. So that is why that the reflective the reflected rail will go closer to the normal. Now, having this thing now, that means I'm going to have a normal somewhere here. Let me have a normal somewhere here. Don't know how to draw the normal. Okay, let me have a normal somewhere here. Let me have a normal somewhere here. Let me have a normal somewhere here. Now, if you have a normal somewhere here, you will see that this one will now be small. This one will now be small, while no, no, sorry, that's a mistake. If I have a normal, my normal should be somewhere here. Yes, my normal should be somewhere here. How do I know that my normal should be somewhere here? Why? Because this angle should be an alternate angle with this one. So that is where my normal is. So now, if I now have my normal here, then this thing will now show that the incident rail will now be somewhere here. Okay, the refracted rail will now be somewhere here. Will now be somewhere here. Okay. So I now have that. Let me see. I have this. Yes. Okay. This one comes this way. Wow. Okay. Let me have my normal the other way. I'm not very good at drawing. Let me have my normal like this. Let me have my normal like this. Okay. If the normal is like this, they say that this side is now your E. This is my E. And then I have that this one is going like this. Okay. And they say that this place is your D. This is your D. All right. Okay, and this is angle A, which is something as here, according to what they say, that here is equally angle A. Okay, now there are things you need to know. You need to know that your I, my I is incident rail, okay, or angle of incident. Your I is the angle of incident. Your R and R1 and R2, they are all equal. They are all known as what? Angle of refraction. Then we now have that our A is what? Refracting angle of the prism. Refracting angle of the prism, which is something as this angle as well. In this case, in an equilateral triangle, is 60 degrees. All right. Our A is called, please write them down. Our A is equal to what they call it, refracting angle of the prism. Okay, refracting angle of the prism. Then in this case is 60 degrees for this particular case, because we are using an equilateral triangle. Okay. Okay. Now note, there is something we call minimum deviation. They say, note, an angle of minimum deviation of a rail of light occurs when the rail passes symmetrically through the prism. Okay, it passes symmetrically through the prism. That is when we have a minimum angle of deviation. But there are some things you need to note at minimum angle of deviation. Note, there are things you need to note at minimum angle of deviation. At minimum angle of deviation, there are things you need to know. Number one, you need to know is that your I is equal to E. At minimum angle of deviation, your I is equal to E. That is what one thing you need to know. Then secondly, at minimum angle deviation, you should know that our r is equal to a over 2. Okay. Or if you want to get your a, which implies that this thing implies that our a is equal to 2r. Okay. This implies that our a is equal to what? 2r. Then another thing you need to know, number 3, you need to know at minimum deviation is that that minimum deviation is equal to, let me represent it with capital letter D anyways, is equal to what? 2i minus 2r. Okay. Is given by 2i minus 2r. Okay. If it's given by 2i minus 2r, then let us now get what our I is. We already know what is our r. From here I can get my I. For me to get my I, this one can come here to see that 2i is equal to what? D plus 2r. All right. So therefore my 2i is equal to what? D plus 2 into my r is what? My r is a over 2. A over 2. If this cancel this, we will now have that what? My I, permit me to finish it up here. So we will now have that what? Our 2i is equal to what? D plus a. Very important formula which shows that our I is now what? D plus a over 2. Very important formula you need to know. All right. Now, since we have known this, another thing we need to know is that you know that what? The incident rail from A to G is equal to what? Sine I over what? Sine what? R. Very, very important formula from Snail's law. So this is equal to what? Sine, what is my I? My I is A plus D or D plus A, anyone you like, A plus D over 2 divided by my sine what? Sine R. What is my R? My R is what? A over 2. My R is A over 2. So this is the formula to calculate the what? The refractive index of what? A rectangular prism. So we can now solve some calculations to illustrate what we have learned so far. All right. So let us move. We move. Please go and watch my first video on refraction. It will really help you to understand what we are doing. So the first question I'm going to solve, question number 1. I love solving questions. Calculation time is a blessing time. So if you want to be blessed, you solve more calculations. So the first question I'm going to solve said a ray of light is incidented okay is incident on air glass surface at angle 30 degrees. Full stop. Then I say find the angle of refraction if the refractive index of glass is 1.5. Okay, that is 3 over 2. 1.5. Solution, very, very simple. You know our Snail's law. Our Snail's law said that what? From air to glass is equal to what? Sine I over what? Sine R. So they gave me this one as 1.5 is equal to sine. It is incidented at 30. So sine 30 over what? Sine R. So therefore, my sine R is equal to what? Sine 30 divided by 1.5. So therefore, my sine R is equal to, so sine 30 divided by 1.5. So I'm having 1 over 3. 1 over 3. So my R will now be what? The sine inverse of 1 over 3, which is equal to sine inverse of my answer. I'm having 19.5 degrees. 19.5 degrees. Very, very simple. All right. So go to the next question. Question number 2. I think we are going to solve how many questions here? Let me check. Okay, we'll be solving maybe around 14 questions or so. So get ready. The more questions you solve, the more familiar you are with the questions. So I have a ray of light. A ray of light makes a ray of light makes an angle of 35 degrees with the normal when it is passing from air to water. When it is passing from air to water, let's say if the refractive index of water is 1.33, calculate the angle of refraction. Angle of refraction of the ray passing through the water. Okay? Solution. They gave us that so we are talking about from air now to water. So the angle of incidence from air to water is equal to what? Sine I over what? Sine R, right? So this one they gave us 1.33 is equal to sine our I. They say that if the index of the water is 1.3, they calculate the refractive. Okay, so they gave us the incident angle. A ray of light makes an angle of 35 degrees with the normal. So it makes an angle of 35 degrees with the normal. So any angle made with the normal is what? Your incident angle. So they gave me the incident angle as 35 all over what? Sine R. Okay? So therefore, my sine R will now be sine 35 over what? 1.33. So we say that what? My sine R is equal to what? Sine 35 divided by 1.33. So I have 0.4313. So therefore, my R becomes the sine inverse of that 0.4313, which is equal to shift sine answer. So I have 25.5 degrees. 25.5 degrees. Very, very simple. Approximately 26 degrees. So we move to the next question. Question number 3. We do start from the cheaper question to more difficult questions. So question number 3 said the refractive index of a glass material is 1.5. Then I say if the velocity of light in a vacuum is 3.0 times 10 raised to power 8 meter per second, okay, comma, then I say what is the velocity of light in the glass. Okay, solution. This is very, very simple. We know that what? Refractive index from what? Air to glass is equal to what? Velocity in air over what? Velocity in glass. So they gave me this one as 1.5 is equal to velocity in air. even if you don't, even if they did not give it to you, you should know that is what? Velocity of light in air. And the speed of light or velocity of light is always given by 3.0 times 10 raised power 8. Whether they gave it to you or not, you should know that all over what? The velocity of light in glass. So if I cross multiply, I'm going to have Vg is equal to 3.0 times 10 raised power 8 divided by 1.5. So you now have your answer. So I'm having 3.0 divided by 1.5. So I'm having 2. So this is 2 times 10 raised power what? 8 in what? Meter per second. So that is that for that. We'll go to the next question, question number 4. See, these things are very, very simple. So question number 4. Question number 4 said a coil. Okay, a coin. Question number 4 said a coin is placed. A coin is placed at the bottom. Is placed at the bottom of a pond, comma 3 meter deep. Then I say calculate the I question apparent. They say apparent depth of the coin. I. They say we should calculate apparent displacement. Apparent displacement of the coin when it is viewed vertically from above, and then I gave us that this of water is 4/3. Okay, so this is very, very simple. Now what do we do? Solution. For the first question, we did this in the previous video, so you can watch it for you to understand very well. Okay, do I need to start drawing it for you? Okay, I don't need to start drawing it, but you just know that what this what is this called? Refractive index from what? From air to water is given as the real depth. I did this in the previous video. Please go and watch it. All over what? The apparent depth. All right. So this gave us as 4/3 is equal to the real depth. They say that a coin is placed at the bottom of a pond 3 meter deep. This is the real one. So this is the real one they gave us because it is 3 meter. That's the real one. Then they now say we should calculate the apparent one. So how it appears. That's what is mean by apparent. So the apparent depth. Okay. If I cross multiply, I'm going to have that apparent depth is equal to what? 3 times 3/4, which is what? 9/4. So 9/4 will give us 9 divided by 4 will give us 2.25. So this is 2.25 in what? In meters. Now another thing they say we should calculate I is now the displacement. Whenever you hear displacement means the real minus the apparent. Very simple. So they say we should calculate the displacement. The displacement is simply is equal to what? The real minus the apparent. So which is equal to what? The real is 3 minus the apparent, which is 2.25. So what do we have? So 3 minus my last answer, I'm having 0.75. So 0.75 meters. Very, very simple to calculate. So we'll move to the next question. Question number 5. You see? All these things we did it in the previous video, so we have not even gotten to the one in this video self. So but let's just continue to refresh your memory. All right, question number 5 said let me check my time, please. Okay, question number 5 problem sorry about that. Question number 5 oh. Okay, so question number 5 said a microscope A microscope is focused on a table then I say when a mark is covered a by a plate of glass, comma 3 cm thick, comma then I say the microscope has to be placed 1.18 cm for the mark to be once more in focus. Then I say calculate the refractive index of the material glass. Okay, solution. Now this is a very simple question. Now what do we do? They gave us that the thickness, okay, they gave us that the thickness is the real, okay, the thickness is the real, that is the real depth. The thickness is the real depth, which is 3 cm, right? Then I say that the microscope has to be placed 1.8 cm from the mark. It has to be placed 1.8 cm from the mark. So to get the apparent, you say the real minus this one. This one they gave us is the displacement. What they gave us now is the displacement. Sorry. What they gave us now is what? The displacement. The displacement they gave us is 1.18 cm. So to get the apparent is equal to what? 3 minus 1.18, which will give us 3 minus 1.18. I'm going to have 1.82 cm. So I know that my refractive index from A to the glass is equal to what? The real depth over the apparent depth, which is equal to what? 3 divided by 1.82. So what do you have? 3 divided by my last answer. I'm having 1.65. Okay? cm. Okay, cm will cancel cm, so it does not have any unit. So question number 6. Question number 6 said an object is placed directly below a glass block of thickness. I told that the thickness of the block is the real thickness, 3.0 cm. The way you understand this thing perfectly is when you watch the previous video. Calculate the lateral displacement of the object if the refractive index of the glass is 1.5. Solution. Now, this is very, very simple. They gave us the real depth, which they gave us as 3.0 cm, and they gave us the refractive index from A to the glass as what? 1.5, 1.5. But I know that this man, A to G, is equal to what? The real depth over what? The apparent depth. So which is 1.5 is equal to what? The real they gave us is 3 divided by the apparent. So what do we have? If we cross multiply, we are going to have that the apparent is equal to 3 divided by 1.5, which the apparent is going to be 3 divided by 1.5. So I have 2. It's going to be 2. Now, but you know that they say we should calculate displacement. I told you that displacement is simply the real minus the apparent. Okay, which is what? 3 minus 2, which is what? 1 cm. So 1 cm is the correct answer. So we move to the next question. Question number 7. So for question number 7, we have that it says surface waves traveling in deep water at 15 meter per second are incidented on a shallow water, okay, shallow water boundary. Then I say if the angle of incidence and refraction are 45 degrees and 30 degrees respectively. Okay? Then I say calculate the speed of the wave in the shallow water. Solution. Now this is very, very simple. They say that what? Surface wave traveling in a speed of this. So this is the speed in air. The speed in air is equal to what? 15 meter per second. So the speed in the shallow water is what we don't know. But we know that angle of incidence they gave us is 45 degrees, and angle of refraction they gave us is what? 30 degrees. There's a formula that says that n from A to water is equal to what? Velocity in air over what? Velocity in water, which they equally say that it is equal to what? Sine of incidence over what? Sine of what? Refraction. So let me put everybody here and cross multiply. I have my 15 over what? Velocity of water is equal to what? Sine 45 over what? Sine 30. So let me cross multiply to get my velocity in water. So the velocity in water will now be, this will go this, okay? So it will now be 15 times sine 30 divided by sine 45. So what do we have? 15 sine 30 divided by sine 45. So I'm having 10.6 meter per second. So this is very, very simple to calculate. So we'll go to the next question. Question number 8. Question number 8 said that a point object placed in contact in contact with one surface of a glass, okay, of thickness. Don't forget that the thickness is the real, of thickness 1.6 cm, okay, and the refractive index 1.61 is viewed along the normal to the opposite. Is along to the normal to the opposite surface. They say by how much does the point object appear to be displaced? Okay, by how much does it appear to be displaced? Once you hear displaced, you know that they're asking you the displacement. So this is very simple. They have given us the real depth. They have given us the real depth as what? That is the thickness, which is 1.6 cm, and they gave us our this from air to water or glass. Which one? A point is placed surface glass. Okay, to glass is equal to what? 1.61. So, but we know that this of from A to G is equal to what? The real depth over what? The apparent depth. Okay, so this they gave me is 1.61 is equal to what? 1.6 divided by apparent depth. Okay, so if I cross multiply, I'll be having that my apparent depth is equal to what? 1.61 divided, sorry, 1.6 divided by 1.61, which will give me 1.6 divided by 1.61. So I'm having 0.99. Okay, so having 0.99, you should now know that your displacement is equal to what? The real minus apparent. So the real I have is 1.6. The real is 1.6 minus the apparent is 0.99. So you now have 1.6 minus answer. So I have 1.61, right? Sorry, 1.6 minus 0.99. What am I right? Okay, 0.61 cm. So that is that, 0.61 cm. So question number 9, we are moving. So question number 9 said, so question number 9, where is it? Aha. So question number 9 said a 60 degrees prism has refractive index 1.5. Then I say, what is the angle of minimum deviation? What is the angle of minimum deviation, comma, that is dm? Okay, what is the angle of minimum deviation? Then I also say calculate the angle the angle of refraction. Calculate the angle of refraction of the light passing through the prism at minimum deviation and the angle of incidence. Okay, solution. Now they told us that a 60-degree glass block, I told that is our A. The glass block is your A. Okay, I told you that in the one we did, that this one is a right angle triangle. So this is our A. Our A is 60 degrees. Okay, once you know that your A is 60 degrees, it will help you to calculate your R. Your R is always half of your A. Okay, which is what? 30. That is 60 divided by 2. 60 divided by 2, which is what? 30. Okay, now since you have this, they said we should calculate what? Calculate the minimum deviation. Calculate the minimum deviation. How do we calculate the minimum deviation? How do we calculate the minimum deviation? Okay, did they give us calculate the angle of refraction, okay, of the light passing through the prism at minimum deviation and the angle of incidence? Okay, we should know that what the refractive index of a prism, of a glass prism, is always 1.5. Okay, if they did not give it to you, just know that it is 1.5. If there is no way to calculate it, you use 1.5. So if you are using 1.5, I will know that what my D is from A to G is equal to what? Sine of the incident over what? Sine of the refracted ray. So we are done. So we now have that 1.5 is equal to what? Sine. What is my I? I'm looking for my incident. Okay, all over what? Sine 30. So if I cross multiply, I'll be having that sine 30, sorry, sine I is equal to what? 1.5 times sine 30. So sine I is equal to, let us do that, 1.5 times sine 30. So I'm having 0.75. So therefore my I will now be the sine inverse of 0.75. So which is equal to, so shift sine, so I'm having 48.6 degrees. Okay, now you should know that your you should know that your 2I is equal to what? Your D plus A, right? Yes, your 2I is equal to your D plus, or A plus D. A plus D. You should always know this, that 2I is equal to A plus D. So therefore, we will now have that my 2 times 48.6 is equal to what? My A. Do I have my A? My A is 60. 60 plus my D. So if I collect items, this 60 will come here. So I have this answer times 2 to give you 97.18 is equal to what? 60 plus what? D. So my D will now be what? 97.18 minus 60. So which will give you minus 60. So you have 37.18 degrees. So that is that. That is my D and my D and my whatever. So question number 10. See, all these things are very, very simple. All these things are very, very simple. Once you know the formula, you know them. You are good to go. Number 10. Number 10 said a ray of light experiences a minimum deviation when passing when passing symmetrically through an equilateral triangular glass triangular prism. Then I say calculate the angle of incidence. Okay, calculate the angle of incidence of the ray. Okay, calculate the of the ray. Solution. Now, this is very, very simple to calculate. We should know that first of all, our A, since it is an equilateral triangle, our A is already 60 degrees. And if your A is 60, your R is half of your A. This one is very, very simple. Half of your A, which is what? 30 degrees. Okay? They say a ray of light experiences what? A minimum deviation. Okay? Now, there's another thing you need to know. You should know that since they did not give us the incident ray, refractive index. The refractive index of glass is what? 1.5 if it's not given. So, but we know that refractive index of glass is equal to what? Sine R, sine I over what? Sine R. Okay? So, I'm done. So, this is 1.5 is equal to what? Sine I over what? Sine 30. So what do we have? If you permit me to finish it up here, I'll be having that cross multiply that your sine I is equal to 1.5 times sine 30. So which will give you what? 1.5 times sine 30 will give you, I think, 2, right? We did it before, 2. So your I will now be the sine inverse of 2. Let me check, let me sure. 1.5 times sine 30. Oh, 0.75. 0.75. Okay, 0.75. So therefore, sine inverse of that, sine inverse of your answer will give you 48.6 degrees. 48.6 degrees is your angle of what? Calculate the incident ray. So they did not give us any number here, but you see that we have numbers. So we'll go to question number 11. Carry me. Yeah. Go to your one. So we move to question number 11. Question number 11 said light wave of frequency. I thought that the frequency are always the same thing. So it's only the wavelength and the velocity that differs. So frequency of 5 times 10 raised power 12 hertz, okay, moves through water, of which the refractive index where is it? Refractive index is 1.33. Then I say calculate the wavelength. Calculate the wavelength in water. Calculate the wavelength in water if the velocity of light in air is 3 times 10 raised power 8 meter per second. Okay? All right, solution. They say that light moves, they gave us the frequency F is equal to what? 5 times 10 raised to power 12 hertz. Okay. They gave us the refractive index as what? As 1.33. Okay. And they gave us the velocity of light in air should be 3 times 10 raised to power 8 meter per second. Even if they did not give it to you, your mind should go there, even if they did not give it to you. Okay. Now with this, I think we are good to go, because I know that this is equal to what? Velocity in air all over what? Velocity in water. So this is 1.33 is equal to what? 3 times 10 raised to power 8 divided by velocity in water. So my velocity in water is equal to what? 3 times 10 raised to power 8 divided by 1.33. So what do you have? So 3 divided by 1.33. So I have 2.26 times 10 raised to power 8. Okay? Now, this is the velocity in water, meter per second. Meter per second. And they say we should calculate what? What they say we should calculate? The light is the frequency, light wave or frequency. You know that the frequency in air must be the same thing in water. I hope you know that. The frequency in air must be the same thing in water, because I thought that or in glass, I thought that the frequency does not change. It's only the wavelength and what changes, and the velocity is what changes. So what they say we should calculate, which calculates the wavelength in water. So we know that V is equal to what? F lambda. If you know that V is equal to F lambda, we have gotten the wavelength, sorry, the speed in water, which is our V. So I have that my, what they say we should calculate the wavelength. So our wavelength will now be what? V over what? F, which is equal to what? My V is what? 2.26 times 10 raised to power what? 8 divided by, I thought that the frequency remained the same everywhere. The frequency remained the same. So 5 times 10 raised to power what? 12. So if you do that, you are going to have divided by 5. I'm having 0.45 times 10 raised to power 8 minus 4. That is minus 4, right? Which is what? 4.5 times 10 raised to power what? Minus 3 meters. So that is that for that. So you see, it's very, very simple. Okay, sorry, 5, because I moved this way. 5, right? You can check it out. Let's check it out, please. 2.26 times 10 raised to power 8, okay, divided by 5 times 5 divided by 10 raised to power 12. Okay, yes, 4.52 times 10 raised to power minus 5. Okay, so we'll go to the next question. Question number 12. These things are very, very easy to calculate. Question number 12. So question number 12 said that if the refractive index of a medium is 4/3, comma, they say calculate the minimum or least angle of incidence, okay, in the medium beyond which total internal total reflection can occur. Okay, so what do we do? Okay, they say that solution, they say that what am I saying? They say that n is equal to 4/3. Okay, they say if the refractive index of a medium is this is the refractive index, they say we should calculate the minimum angle of incidence in the medium beyond which total internal reflection. Whenever you hear internal reflection, the total one is when it is perpendicular. And if it is perpendicular, then you are looking for what? Angle of what? They call it C. In the other video I taught you, they call it C. And that C is, what do we call it? Think critical angle. Yes, we call it critical angle. So what they're asking us is the total internal reflection. The total internal reflection is gotten from the critical angle. Okay, so what is the critical angle is what they are asking us. But do you remember that this man is equal to 1 over sine the critical angle? So therefore the sine of the critical angle is equal to what? 1 over what? This. Okay, therefore sine critical angle is equal to 1 over 4 over 3. So permit me to finish it here. So therefore sine the critical angle is equal to 3 over 4. So therefore my C will now be the sine inverse of that 3 over 4. So which is equal to what? Sine inverse of 3 over 4. Shift sine sine 3 over 4. So you're having 48.6 degrees. So that is that 48.6 degrees, approximately 49 degrees. So we'll move to the next question, question number 13. We did all these things in the previous video as well. Question number 13. Question number 13 said calculate the critical angle. Calculate the critical angle of a material of a glass if its refractive index is 1.5. This is a very simple question. It's as good as what we just solved now. Okay, solution. You should know that what? That sine of the critical angle is equal to 1 of the refractive index. So therefore sine C is equal to 1 over 1.5. So therefore sine C is equal to 1 divided by 1.5. I'm having 2 over 3. So therefore C will now be sine inverse of 2 over 3, which is equal to what? Shift sine my answer. So I'm having 41.8 degrees. So approximately 42 degrees. So go to question number 13. Question number 14 rather. Oh, okay. So we have just, I think, 2 more questions, then we are good to go. So question number 14. Question number 14 said, look at what they gave us. So they said that here, and I have that here is 60 degrees, and they call this place I. Okay, they now gave us this place and said that this is our R, refractive index. They now gave us here again, and they now said that here is 90 degrees to this place, and they now said that this is equally our arrow again, coming this way, this one going this way. They said in the figure above, comma, a ray of light, okay, in a ray of light in air strikes a glass plate at an angle of incidence of 60 degrees. Then I say the reflected rail. Okay, this one, they say that this one is the refracted ray. Why this one is reflected ray? Why they say that this one is incident 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 ray? Okay, they say that the refracted ray, question number 14, the reflected ray is observed, okay, is observed to be perpendicular 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 to the refracted ray. Then I say what is the refractive index of the glass Okay, now having this, this is very, very simple. So what do we do? Okay, so what do we do now? uh, okay, now if we have this, let's have this now. Having that this man is what, your 60 degrees, okay, and then this is the reflection. I hope you know the law that said that angle of incidence is equal to angle of reflection. So that means that here is equal to 60 as well. So if here is equal to 60 and we have here, and they say that here is 90 to this man, so if here is 60, automatically here is 30, and if here is 30, automatically it means that here is another 60 degrees. Is that? Yes, it's another 60 degrees, right? Okay, if we have that place is 60, automatically here is now 30. So the angle of refraction is just 30 degrees. The angle of refraction is just 30 degrees. So if they now say you should calculate the incident uh, refractive index, so refractive index will now be what? Sine I over what? Sine R, which is what? Sine 60 over what? Sine 30. So do the math and get your answer. So that is that. So we'll move to question number 15. So question number 15, which is the last question I'm going to solve. So question number 15. Where is question number? Question number 15. Question number 15 said that the wavelength and velocity of a set of plane waves traveling in a medium are 6 cm, okay, 60 cm and 320 cm per second respectively. Then I said it meets a plane refracted, okay, it meets a plane refracting surface. It meets a plane refracting surface at angle of incidence of 60 degrees. Then I say its velocity after refraction is 280 cm per second. Then I say calculate the wavelength. Calculate the wavelength of the waves in the second medium, and also the angle of refraction. Okay, and also the angle of refraction. Where is it? To stop. Now, there is a formula I gave you. I told you that the frequency remains the same, but the problem is that the wavelength does not remain the same. So, but we know that this man in from A to a glass, for instance, or two different medium, anyone, okay, is equal to what? Velocity, or let's say A and B, two mediums, A and B, okay? Velocity in A over what? Velocity in B. Do you remember this thing? Where I told you, according to velocity, velocity is F lambda. F lambda of A over what? F lambda of B. I thought that the F are always the same. If they cancel out, it will give me a formula that says that A of B, V of B is equal to what? Lambda of A over lambda of B. So if you put everything, you see that the first V they gave me is 320 over the second V they gave me is what? 280. 280 is equal to the first lambda they gave me is 60 all over the second lambda is what I'm looking for. So if I cross multiply, I'll have that the lambda B would now be what? 60 times 280 divided by 320. So what do we have? 60 times 280 divided by 320. So I'm having 52.5 cm. Okay, this is very, very simple to calculate. 52.5 cm. All right, so having this now, what do we do next? What we do next is that they say we should calculate the refractive index. Okay, don't forget that this man, sorry, they say we should calculate what? The angle of refraction. Do you know that this man is equal to what? Sine I over what? Sine R, which is equal to, if I like, I use wavelength. If I like, I use V, which is equal to VA over VB. So having known this, we should now see that sine I, sine incident ray, where is the incident ray they give us? Incidented at 60, so sine 60 degrees all over what? Sine R that we are looking for is equal to V of A, which is 320 over V of B, which is 280. Okay, so what do we have now? If you cross multiply, you are going to have that your sine R will now be what? 280 times sine 60, now divided by what? By 320. So what do we have? So we now have 280 divided by 320, then times sine 60. So I'm having that sine R is equal to 0.7577, sorry, 78. So therefore my R will now be the sine inverse of 0.7578. So my R shifts sign of my answer. I have my R is now 49.3 degrees. So thank you very much for watching. Please don't forget to like, share, and subscribe. Bye-bye.